In this video, let us discuss about mirror formula, magnification and sign convention. Let's say we have concave mirrors and convex mirrors, right? These are spherical mirrors. ఈ mirrors objects ఏదైనా ఒక ఆబ్జెక్ట్ ఇస్తే కనుక దాని images ని generate చేస్తాయి, right? What is the location of the image? What is the size of image? Whether it is a real image or virtual image. ఇలాంటి ఇన్ఫర్మేషన్ కావాలంటే ఈ వీడియోలో డిస్కస్ చేసే ఫార్ములాస్ ఆర్ గోయింగ్ టు బి యూస్ఫుల్. మిర్రర్ ఫార్ములా కానీ మ్యాగ్నిఫికేషన్ ఫార్ములా కానీ దే ఆర్ గోయింగ్ టు బి యూస్ఫుల్. ఈ వీడియో చివరి వరకు చూడండి సో దట్ యూ అండర్స్టాండ్ ద కాన్సెప్ట్ వెల్. ఓకే, ఈ ఫార్ములాస్ బేస్ చేసుకుని మనకి ఎగ్జామ్స్లో న్యూమరికల్ ప్రాబ్లమ్స్ వస్తాయి. సో ఇట్ ఈస్ వెరీ ఇంపార్టెంట్ టు లర్న్. గాట్ ఇట్? Let us first learn about mirror formula. దీన్నే mirror equation అని కూడా అంటారు. It is defined as 1 by f equal to 1 by u plus 1 by v. ఇక్కడ f అంటే f is the distance between the pole and focus of the mirror. U is the distance between the pole and the object. V is the distance between the pole and image. You see, ఇక్కడ చూస్తే కనుక ప్రతి దాంట్లోని పోల్ అనేది కామన్గా ఉంది, రైట్? ప్లీజ్ టేక్ ఎ నోట్ ఆఫ్ దాట్. లెట్స్ సే ఐ హ్యావ్ ఏ కాన్కేవ్ మిర్రర్, రైట్? దిస్ ఈస్ ద కాన్కేవ్ మిర్రర్. Concave mirror has pole, that is the center point on the mirror. This is denoted using capital P. And concave mirror will have one measurement that is called center of curvature. Right, center of curvature అనేది ఏంటి? That denotes the radius of the circle on which this mirror is there, or radius of the sphere in which the concave mirror is part of. Okay, and focal length is radius divided by 2. That is the definition given for spherical mirrors. Focal length is radius divided by 2. The distance between C and P is radius. Cp is radius, Cp by 2 is focal length, or that is where the focus of the mirror is, and that is denoted using capital F. Okay, now if you connect all these points with a straight line, that straight line is called principal axis of the concave mirror. Okay, now F is the distance between pole and focus, right? So the distance between focus and pole, this is denoted using small f. Okay, u is the distance between pole and object. Ante we have to first place the object. Let me say that I have an object here that is denoted using AB. The distance between pole and the object is denoted using u. Okay, పోల్ నుంచి ఆబ్జెక్ట్ ఏబికి మధ్యలో ఉన్న డిస్టెన్స్ ఎంత? u. అండ్ v ఈజ్ ద డిస్టెన్స్ బిట్వీన్ పోల్ అండ్ ఇమేజ్. సో ఏబి అనేది ఆబ్జెక్ట్ అయితే కనుక ఏ ప్రైమ్ బి ప్రైమ్ అనేదాన్ని మనం ఇమేజ్గా కన్స్ట్రక్ట్ చేస్తున్నాం, రైట్? లెట్స్ సే దట్ వెన్ యూ హ్యావ్ ఇన్ ద కేస్ ఆఫ్ కాన్కేవ్ మిర్రర్, వెన్ ద ఆబ్జెక్ట్ ఈజ్ బియాండ్ సి, సెంటర్ ఆఫ్ కర్వేచర్, దెన్ the image is going to form between C and F. Okay, you may be aware of this already. Otherwise, we have a video on this. మీరు ఒకసారి ఆ వీడియో పూర్తిగా చూడండి so that you will understand about concave mirror. Now, the position of the image is here, right? The distance between the pole and image is denoted using V. Understood all the quantities you understood about the mirror formula for concave mirror? Now let's look at the same for convex mirror. Convex mirror also will have a pole, it will have a curvature, center of curvature and focus, right? This is P and this is focus and this is center of curvature. And the line connecting all these three is called principal axis, and this is the principal axis of the convex mirror, right? Now, the same formula is valid here also. 1 by f equal to 1 by u plus 1 by v. Now, here f is the distance between pole and focus of the mirror, meaning from P the distance between P and F is called focus of the mirror. This is small f, denoted using small f. And U is the distance between pole and object. Let me place an object. Let me call this as AB. The distance between this particular point and pole. This is our U, right? And once you have an object, even in the convex mirror also, you will be getting images, right? Where the image will be, image is located here, behind the mirror, right? That's why you say that convex mirror is going to give always virtual images. Okay, now the distance between pole and the image is V. You see, there is a difference between concave mirror and convex mirror, right? Let us learn about sign convention. I have a concave mirror. In this case, we have seen this is C, this is F, and this is P. And the distance between pole and focus is denoted using small f. And the distance between object and the pole is denoted using V, U. And the distance between image and pole is denoted using V, right? This is for concave mirror. Now let's look at convex mirror. In the convex mirror, you have pole, focus, and center of curvature. And the distance between pole and focus is denoted using small f, right? The distance between pole and the object is denoted using U. And the distance between pole and the image is denoted using V, right? Now, when you look at these two, what we have done is we have taken always the distance from the reference point pole. Please note this. This is one of the rules. All the distances should be measured from the pole. Okay. And there is another rule that says that the distance measured in the direction of incident light to be taken as positive, and the distances measured in the direction opposite to the incident light are taken to be negative. Please note this. In both the cases, actually, manaki incident light e direction lo undi, right? For example, if I say that focus, the distance between focus and pole, the distance between, for example, distance between pole and focus is 4 centimeters అని ఇచ్చారు అనుకుందాం. Okay. In the case of convex mirror, if you observe, the light, incident light direction is in this direction, and we are measuring the distance from pole to focus in this direction only, right? That's why the small f is 4 centimeters. Okay. Here, in the case of concave mirror, if you look at the distance between pole and focus is 4 centimeters అని ఇస్తే గనక, the incident light is going in this direction. But the distance between pole and focus we are measuring in this direction, right? Meaning opposite to the direction of incident light. That's why here f is going to be minus 4 centimeters. This is sign convention. Please note this. This is very important. This sign convention అనేది చాలా important. Image ఎక్కడ ఫామ్ అవుతుంది? And image, for example, image real image, virtual image, inverted, upright ఉందా, ఇలాంటి చెప్పాలి అంటే కనుక సైన్ కన్వెన్షన్ ఈజ్ వెరీ ఇంపార్టెంట్. ప్లీజ్ నోట్ దిస్. మీకు అర్థమైందా? ఈ పర్టికులర్ కేసులో ఎఫ్ ఈజ్ 4 సెంటీమీటర్స్ అని రాసాం. కాన్కేవ్ కేసులో ఎఫ్ ఈజ్ minus 4 సెంటీమీటర్స్ అని రాసాం. ఎందుకు రాసాం? యాజ్ పర్ దిస్ రూల్, the distance is measured in the direction of incident light has to be taken as positive. అందు గురించి ఇన్సిడెంట్ లైట్ ఉన్న డైరెక్షన్లోనే డిస్టెన్స్ పోల్ నుంచి ఎఫ్ సైడ్కి మెజర్ చేస్తున్నాం కాబట్టి we said f equal to 4 centimeters here, small f, right? In this case, the incident light is going in this direction, but for the measurement of small f, we are coming from pole to this side, opposite side. That's why this is minus 4 centimeters. Understood? Let us solve a problem to understand this concept well. An object is placed at a distance of 30 centimeters from a concave mirror of focal length 20 centimeters, where will be the image formed అని అడిగారు. ఓకే, దీన్ని మనం మిర్రర్ ఫార్ములా యూస్ చేసి సాల్వ్ చేస్తాం. మిర్రర్ ఫార్ములా ఏంటి? 1/f ఈక్వల్ టు 1/u ప్లస్ 1/v, రైట్? వేర్ f is the distance between the pole and focus of the mirror, u is the distance between the pole and the object, and v is the distance between the pole and image. Okay, let's say I have a concave mirror as shown here. This is the pole and this is focus and this is center of curvature, right? Now focal length is 20 centimeters అన్నారు, అంటే the distance between P and F ఇది 20 centimeters. But okay, minus 20 na 20 na అనేది we have to understand, right? And the object is placed at 30 centimeters from concave mirror అన్నారు. Okay, it means object is placed somewhere here between C and F. Now we are asked to find where the image is going to form. Okay, now the sign convention says that the distances measured in the direction of incident light is to be taken as positive. Incident light to e direction lo vastundi, right? The distances measured in the direction of incident light is to be taken as positive. మనకి ఇక్కడ ఫోకల్ లెంత్ 20 సెంటీమీటర్స్ అని ఇచ్చారు, రైట్? అది P నుంచి F కి మధ్య ఉన్న డిస్టెన్స్. వీఆర్ గోయింగ్ ఇన్ అపోజిట్ డైరెక్షన్ టు ద ఇన్సిడెంట్ లైట్. దట్స్ వై లెట్ మీ రైట్ ఇట్ యాజ్ F ఈక్వల్ టు -20. ఓకే, U ఈజ్ ద డిస్టెన్స్ బిట్వీన్ పోల్ and object. Okay, let me say that this is the distance between pole and object. We denote that using U, and U is also going to be a negative number because we are measuring distance in this direction which is opposite to the incident light, right? So U is going to be -30. Now what we are asked to find, where the image will be formed. We want to find what is the V, right? So we are going to make use of this formula. It says that 1/f equal to 1/u plus 1/v, right? Now let me rearrange this. This can be written as 1/v equal to 1/f minus 1/u, right? Let me substitute the numbers. F is -20. Let me write -20. This I can write as -1/20 plus 1/30, right? You see, this is -1/20 and this is here we have 1 minus and we have minus here. When you multiply, it is going to be plus, right? I can write this further as 1/30 minus 1/20. Okay, now once you have this, 30 into 20 can be written as the denominator, right? And in the numerator it is going to be 1 into 20 minus 1 into 30, right? This can be written as 20 minus 30 divided by 30 into 20, right? This I can write further as -10 divided by 600. This can be written as -1/60. So V is going to be 1/V is going to be -1/60. Means V is -60 centimeters. Okay, V is -60 ante dan meaning enti? The image is going to form in the direction opposite to the incident ray. Ante ee direction lo 60 centimeters daggara untundi. So the image is going to form somewhere at this location. Okay, the image, whether it is going to be inverted or upright, meeku telusa, it is going to be a real image. That's why it is going to be inverted. బట్ మనల్ని అది అడగలేదు. వేర్ ఇట్ ఈస్ గోయింగ్ టు ఫార్మ్ అన్నారు. 60 సెంటీమీటర్స్ డిస్టెన్స్ ఫ్రమ్ ద పోల్. ఇక్కడ ఫామ్ అవుతుంది. సో ఇట్ ఈస్ గోయింగ్ టు ఫార్మ్ బియాండ్ center of curvature of the mirror. Understood? Let us solve the same problem in the context of convex mirror. An object is placed at a distance of 30 centimeters from a convex mirror of focal length 20 centimeters. Where will be the image formed? దీన్ని కూడా మిర్రర్ ఫార్ములా యూస్ చేసి సాల్వ్ చేస్తాం. 1/f equal to 1/u plus 1/v, where f is the distance between pole and focus of the mirror, u is the distance between pole and the object, and v is the distance between pole and image. Right? మనకి f ఎంతో ఇచ్చారు. Distance between object and the mirror 30 centimeters అని ఇచ్చారు. బట్ సైన్స్ ఇంకా తెలియదు, రైట్? దానికోసం let us draw a convex mirror. This is the pole, this is the focus, and this is the center of curvature, right? Now we want to place an object 30 centimeters away from the mirror, right? So this is the distance between pole and the object, that is denoted using u, right? u is 30 centimeters. అయితే u అనేది -30 నా +30 నా ఎలా చెప్తాం మనం? The direction of incident light is in this direction, right? Whereas to measure the distance between pole and the object, we are going in opposite direction, meaning u is -30 centimeters, right? And focal length is 20 centimeters. అన్నారు. అంటే the distance between the pole and focus, this is 20 centimeters, denoted using small f, right? So to measure the small f length, we are going in the direction of incident light. Pole నుంచి focus వరకు ఉన్న distance, right? So we are going in the same direction. It means f is going to be 20 centimeters. Same direction లో వెళ్తుంది కాబట్టి f is 20 centimeters. Now with the help of these two quantities, we are going to find what is the value of v, right? Use this formula. So I am rewriting this formula. 1/v equal to 1/f minus 1/u, right? Let me substitute 1/20 minus 1/-30. This can be written as 1/20 plus 1/30, right? Now I can write this as 20 into 30, right? Numerator lo 30 times 1 plus 1 times 20. So this is going to be 50 divided by 600. Okay, let me write this as 1/v equal to 5/60. Right? I can write this as 1/12. It means v equal to 12 centimeters. Right? v equal to 12 centimeters. v equal to 12 centimeters అని వచ్చింది మనకి. ఇంత ముందు చూస్తే కనుక we got v in the negative as the negative number, right? ఇక్కడ v equal to 12 centimeters అని వస్తే మీనింగ్ ఏంటి? We are going to start from pole and measure 12 centimeters and place the image here. అర్థమైందా? The image is going to be between P and F. మనకు తెలుసు convex mirror కి always the image is going to be on the back side of the mirror, right? And we got it correct. V equal to 12 centimeters, positive number, ante it has to be placed in the direction of the incident light. P నుంచి incident light ఏ డైరెక్షన్లో ఉందో ఆ డైరెక్షన్లో మూవ్ అవుతూ 12 centimeters దగ్గర ఇమేజ్ని మార్క్ చేయాలి. అండర్స్టూడ్? సో సైన్ కన్వెన్షన్ అనేది చాలా ఇంపార్టెంట్. Take a note of this. The distances measured in the direction of incident light has to be taken as positive, and the distances measured in the direction opposite to the incident light are to be taken negative. Understood? Let us now understand about magnification. For spherical mirrors, size of the image formed may or may not be equal to the size of the object. మనకి ప్లేన్ మిరర్స్కి వచ్చేటప్పటికి సైజ్ ఆఫ్ ద ఇమేజ్ ఈజ్ ఈక్వల్ టు ద సైజ్ ఆఫ్ ద ఆబ్జెక్ట్, రైట్? బట్ స్పెరికల్ మిరర్స్ అంటే కాన్కేవ్ కానీ కాన్వెక్స్ మిరర్స్ కానీ తీసుకుంటే కనుక వాటిలో సైజ్ ఆఫ్ ద ఇమేజ్ ఫార్మ్డ్ మే ఆర్ మే నాట్ బి ఈక్వల్ టు ద సైజ్ ఆఫ్ ద ఆబ్జెక్ట్. ఫర్ కాన్వెక్స్ మిరర్స్ we know that size of the image is always smaller than the object. Size of the image is going to be always smaller than the size of the object in case of convex mirrors. But concave mirrors koste, in case of concave mirror, size of the image can be smaller than, equal to or larger than size of the object depending upon the location of the object. Mirror nunchi ante pole of the mirror nunchi enta distance lo manam object ni place chestunamo and what is the focal length of the mirror ane dan base cheskuni size of the image is going to be decided. అది కొన్నిసార్లు స్మాలర్ ఇమేజ్ ఉండొచ్చు, కొన్నిసార్లు ఈక్వల్ ఉండొచ్చు, కొన్నిసార్లు లార్జర్ దాన్ సైజ్ ఆఫ్ ద ఆబ్జెక్ట్ ఉండొచ్చు, రైట్? ఇది తెలుసుకోవడం కోసమే వాట్ ఈస్ ద సైజ్ ఆఫ్ ద ఇమేజ్ అనేది తెలుసుకోవాలంటే కనుక వీ హ్యావ్ ఎ ఫార్ములా దట్ ఈస్ కాల్డ్ magnification formula that is denoted using m. Magnification m equal to hi divided by ho. That can also be written as minus v by u, right? Here hi is the height of image, ho is height of the object. V ante it is the distance between pole and the image, and u ante it is the distance between the pole and object, right? Ee formula meeku gurtundali. మ్యాగ్నిఫికేషన్ సైజ్ పెద్దదైందా చిన్నదైందా, హెచ్ఐ అనేది స్మాలర్ దాన్ హెచ్ఓనా, లేకపోతే హెచ్ఐ అనేది గ్రేటర్ దాన్ హెచ్ఓనా, లేకపోతే హెచ్ఐ ఈక్వల్ టు హెచ్ఓనా, ఎలా చెప్తాం? వీఆర్ గోయింగ్ టు మేక్ యూజ్ ఆఫ్ దిస్ ఫార్ములా m ఈక్వల్ టు మైనస్ వి బై యూ. అండర్స్టూడ్? Height of object h0 or ho and height of image hi are positive if they are measured upward from the axis. They are negative if measured downwards. Okay, అర్థమైందా మనకి? Let's say I have a concave mirror. This is the axis, right? For example, this is the object. Its height is denoted using h0 or ho, and this is the image. Its height is denoted using hi. Okay, ikkada rule emani cheptundante hi or ho whatever you take is going to be positive if measured upwards. h0 anedani ho anedani we are measuring upwards, that's why here ho is positive. ఈ particular case లో hi we are measuring downwards, right? That's why hi is negative ఈ particular case లో. Understood? అలా కాకుండా if both are measured upward, hi and ho both are measured upward అయితే కనుక కొన్ని స్పెసిఫిక్ కేసెస్లో అవుతుంది కదా, అలా అయినప్పుడు both are going to be positive. అర్థమైందా? m is defined as hi by ho, right? It can be positive or negative, ఏదైనా అవ్వచ్చు. ఫర్ ఎగ్జాంపుల్ ఈ పర్టికులర్ కేసులో ho పాజిటివ్ అండ్ hi నెగటివ్ కాబట్టి నెగటివ్ డివైడెడ్ బై పాజిటివ్ ఇట్ ఈస్ గోయింగ్ టు బి నెగటివ్, రైట్? m is negative. In this particular case, since both are positive, m is going to be positive, right? M can be positive or negative. If m is positive, please note this, if m is positive, both the object and image are on the same side of the principal axis. ఇక్కడ రెండు సేమ్ సైడే ఉన్నాయి ప్రిన్సిపల్ యాక్సిస్ కి, అందు గురించి m అనేది పాజిటివ్ అయింది. అలా కాకుండా దేర్ కెన్ బి సమ్ కేసెస్ బోత్ ఆఫ్ దెమ్ ఆర్ ఆన్ ద on the downward side of the principal axis. And this is also negative, this is also negative. So M is positive, right? Negative divided by negative is positive, right? That's why M is positive. M can be positive or negative. M అనేది పాజిటివ్ అయితే దాని మీనింగ్ ఏంటి? బోత్ ద ఆబ్జెక్ట్ అండ్ ఇమేజ్ ఆర్ ఆన్ ద సేమ్ సైడ్ ఆఫ్ ద ప్రిన్సిపల్ యాక్సిస్. ఓకే, M అనేది కనుక నెగటివ్ అయితే కనుక 1 ఈజ్ ఆన్ ద పాజిటివ్ సైడ్ అండ్ 1 ఈజ్ ఆన్ ద అదర్ సైడ్ ఆఫ్ ద ప్రిన్సిపల్ యాక్సిస్. గాట్ ఇట్? Let us solve a problem to understand this concept well. An object of 4 centimeters in size is placed at 25 centimeters in front of a concave mirror of focal length 15 centimeters. At what distance from the mirror would a screen be placed in order to obtain sharp image? Find the nature and size of the image. This has two parts, right? First part lo emani adugutunnaru, screen ekkada place cheyali ani adugutunnaru. Ante image location enti ani adugutunnaru, right? So mirror specification చూస్తే కనుక mirror focal length 15 centimeters అని ఇచ్చారు. Object is placed at 25 centimeters in front of the concave mirror అని ఇచ్చారు, right? ఈ ప్రాబ్లమ్ని సాల్వ్ చేయడానికి we have to use mirror formula. So mirror formula says that 1 by f equal to 1 by u plus 1 by v, right? F is the distance between the pole and focus of the mirror. U is the distance between the pole and object. V is the distance between pole and image. మనల్ని V కనుక్కోమంటున్నారు. What is the value of V అనేది కనుక్కోమంటున్నారు. I have a concave mirror, right? This is pole and this is focus and this is center of curvature, right? Focal length అంతా అని ఇచ్చారు 15 centimeters అని ఇచ్చారు, right? Focal length is the distance between P and F, right? Pole నుంచి focus కి ఉన్న distance ని focal length అంటాం, right? So f అనేది small f, this is going to be small f. Small f is going to be 15 centimeters or minus 15 centimeters. మీరు చెప్పాలి అంటే ఇన్సిడెంట్ లైట్ ఈ డైరెక్షన్లో వస్తుంది, రైట్? మనం పోల్ నుంచి ఫోకస్కి డిస్టెన్స్ ఆపోజిట్ డైరెక్షన్లో కనుక్కుంటున్నాం, రైట్? దట్స్ వై స్మాల్ ఎఫ్ ఈజ్ minus 15 centimeters, right? Now I have to place the object. Where I have to place the object? 25 centimeters from the pole of the mirror. 25 centimeters from the pole ante object I may be placing here. Okay, the distance between pole and the object is denoted using u, right? U value కనుక్కోవడానికి కూడా we are going in opposite direction to the incident light. అందు గురించి u is going to be minus 25 అవుతుంది. Now we have to find what is the value of v, right? దీనికోసం we are going to rearrange this equation. 1 by v equal to 1 by f minus 1 by u, right? Let us substitute the values we know. F equal to minus 15 and u equal to minus 25, right? This now I can write it as minus 1 by 15 plus 1 by 25, right? Let me rearrange this as 1 by 25 minus 1 by 15, right? Then simplify చేయడం కోసం denominator ని I am going to multiply 25 and 15, right? Numerator ఏమవుతుంది? 1 into this 1 into 15 minus this 1 into 25, right? Now this can be written as 15 minus 25 divided by 25 into 15, right? So let me simplify that further. This is going to be minus 10 divided by 25 into 15, right? This is 2 times 5 and this is 3 times 5, right? So minus 2 divided by 75. This can be written as minus 1 divided by 37.5. 1 by v equal to 1 divided by minus 37.5. Ante v is equal to minus 37.5 centimeters. Where we have to place the image or the mirror? ఇన్సిడెంట్ లైట్ కి ఆపోజిట్ డైరెక్షన్ లో 37.5 సెంటీమీటర్స్ దగ్గర మార్క్ చేయాలి అంటే ఇట్ ఈస్ గోయింగ్ టు బి సమ్వేర్ హియర్. ద డిస్టెన్స్ బిట్వీన్ ద పోల్ and the screen is going to be 37.5 centimeters. The screen has to be placed at 37.5 centimeters in front of the mirror. Please note this. This is in front of the mirror. Ante reflecting side edaithe undo aa side. Adhamainda? Now we have to solve the second part of the problem. We have to find nature and size of the image. Right, size of the image కనుక్కోవడానికి మనకి magnification formula ఉంది. Magnification m is defined as hi, that is size of image, divided by h0 or ho, that is size of object, that is equal to minus v by u. Right, hi is height of image we have to find. Right, that is the size of image. Once we know size of the image, we know what is the value of m. Is it going to be positive or negative? Based on that, we can say what is the nature of the image. Understood? H0 is given, right? 4 centimeters is the object height and icharu, right? Now, m is going to be minus v divided by u. V value enta minus 37.5, meaning minus of minus 37.5 divided by minus 25, right? This is going to be 37.5 divided by 25 minus, right? This minus gets cancelled, but you have this minus. Now you see this is going to be 3 times 12.5 and this is 2 times 12.5, meaning minus 3 by 2. This can be written as minus 1.5, right? So magnification m is minus 1.5. Minus 1.5 అని వచ్చింది అంటే you see this m equal to minus 1.5 equal to hi divided by h0, right? We know h0 value. Hi equal to minus 1.5 into h0. Minus 1.5 into 4, that is equal to minus 6 centimeters, right? So hi is 6 centimeters. You understood? Hi is 6 centimeters. Ante this is going to be enlarged. మనకి ఆబ్జెక్ట్ సైజ్ 4 centimeters కానీ ఇమేజ్ సైజ్ 6 centimeters వచ్చింది అంటే సైజ్ ఆఫ్ ద ఇమేజ్ ఈస్ గోయింగ్ టు ఇంక్రీజ్, మీనింగ్ ద ఇమేజ్ ఈస్ enlarged. And nature of the image, for example, this is the my principal axis, right? On this principal axis object is placed like this, and when m is negative it means that the image is going to be on the other side, right? The image is going to be on the other side, meaning image is inverted, and size of the image is 6 centimeters, meaning it is enlarged. You have to write the image is inverted and enlarged. Understood? Understood the concept?